what we're going to start with now is kind of taking a look at the different types of connective tissue proper. So we were talking about some of those differentiated, non-differentiated types of connective tissue. We're going to see that mesenchymal tissue will really become all these three different types that I mentioned in the first video on this one, which is that connective tissue proper, the supporting connective tissue, and the fluid connective tissue. And really, we're going to start with and just kind of work through connective tissue proper in this show, and we're going to see it's really subdivided into two categories. We have what's called loose connective tissue and dense connective tissue, and it really is just going to have to do with fiber. The more fibers there are, we're going to see it's when it's the tissue is mainly fibers with not a lot of cells and not a lot of space. It's going to be a dense connective tissue, where lots of space, not a lot of fibers, not a lot of cells is going to be those different types of loose connective tissue. So, again, loose connective tissue has lots of ground substance and some cells and some fibers. So you can see it right here, but the main thing you notice, it's mainly this kind of white background with stuff in it. That is a type of loose connective tissue. Where dense connective tissue, we're going to see down this picture right here, lots of fibers traveling in every direction. You can see some cells tucked in between stuff, but then not a lot of space. When you look at the stuff, it's stuff that is quite closely packed together. That is going to be your different types of dense connective tissue. So very similar to what we talked about with the epithelial tissue. A lot of this is going to be looking at kind of the structure, what might it be used for, where do we find it in the body. Again, when it comes to tissues in general, that is a lot of what the questions are going to be about. So this loose connective tissue, again, not a lot of fibers, not a lot of cells, lots of ground substance. And I always kind of use the example of like drop ceilings in the college there. You need a place for all your wiring and your plumbing to go, and that's a lot of what loose connective tissue is doing, is supporting structures and providing space for a lot of our blood vessels, nerve supply, everything else like that to travel through. We're going to see technically three main types of this. We'll mention a fourth of elastic tissue, but we have three main types of connective tissue proper. And again, almost all of these are fitting into that. It has cells, has fibers, has ground substance, with the exception of one of these we'll see. So the first one we'll talk about is going to be areolar connective tissue. Areolar connective tissue, like I was saying before, mainly space, has some of all those different fiber types we've talked about, but mainly you're going to see a lot of collagen and elastic fibers, some reticular fibers in there. A lot of those different cell types we're going to talk about are present, but the main thing that you'd notice if you really looked for them, lots of fibroblasts, lots of immune cells spread throughout here. But again, mainly lots of ground substance. You can see a lot of blood vessels in this traveling through these areas. Again, we see this really all over the place, we'll see. So where do we find areolar connective tissue? It's that basement membrane that is underneath all epithelium. It surrounds every blood vessel, all our nerves, surrounds the trachea, surrounds the esophagus. It's between every muscle cell. So the simple answer of where we find areolar connective tissue is pretty much everywhere. This is also what underlies some of those visceral and parietal layers of our different body cavities as well. And again, the loose connective tissue, it loosely binds tissues to underlying layers. And again, provides a passageway for a lot of the plumbing and our electrical to travel through here. Lots of immune cells in this area, again, because it's underlying all epithelium. Makes sense we'd have immune cells in those areas, and it gives us a way to get those blood vessels getting nutrients to those areas above this connective tissue, where we know in epithelial tissue it is avascular, so we need a good blood supply in that layer directly underneath to keep those cells alive and functioning. Reticular tissue, again, mainly reticular fibers in this one. We generally find it in, like I said, those lymphatic organs. This tends to make a scaffolding or framework for these lymphatic organs. So we see it in places like lymph nodes, the spleen, the thymus, the bone marrow, which are all considered lymphatic areas. Like I said, reticular fibers and reticular cells, which are these fibroblasts that make reticular tissue in there. Again, a lot of times white blood cells spread throughout in these areas because, again, a lot of your lymphatic organs are doing immunity things. So like we see a lot of T cells and B cells in things like lymph nodes things like the spleen. What is it really doing? It's making this network that creates, like I said, a scaffold or framework for this lymphatic organ. So you have the framework is the stroma, and then you have the parenchyma, which is the cells that actually make up this organ. So those cells of the spleen and thymus, for example. Again, generally you're always going to see this one staining black, because the one way to get these glycoproteins to show up in here is to do a silver staining, which leads to this black staining that you'll see on these reticular fibers. The last of our different ones here, this is one of those ones that doesn't really fall into our having cells, fibers, and ground substance, is adipose tissue. Adipose tissue is an area where that particular cell that we said we can find in a lot of our connective tissues, the adipocyte. This is an area where the adipocytes are really close and packed together and in big groups. That's what we refer to as adipose tissue. What we end up seeing on these ones, you can kind of see in the picture right here, big lipid vacuole in the center with the cytoplasm tucked out around the side with the nucleus here. Does not stain well. Most of our stains are water-based. Lipids and water don't get along particularly well, so because of that we don't a lot of times see a lot of staining on these cells. I would say some of the time they can almost look like cobwebs under the microscope, these little areas where you're seeing just a little bit of staining and then just a lot of space with no stain. Can see blood vessels in there a lot of the time. A lot of times it ends up looking more like this. Any place where we have a grouping of fat together, so underneath the skin, we have subcutaneous fat layer underneath the skin. A lot of times we talk about that being the hypodermis or subcutaneous layer. In the breast, surrounding the heart, surrounding different organs like the eyes and the kidneys, we are also going to see some of these fat casings around these areas. Again, one of the things that adipose tissue can do is it is a pretty good shock absorber, so it does help protect some of these organs that it surrounds it on. And like I said, shock absorption, definitely protective for those organs. It does help for thermal insulation. Humans, we have some of this. We're halfway decent, but we were more tropical animals through evolution, and so we don't have large, thick layers of this. But if you look at certain other mammals, for example, aquatic mammals, whales with those thick layers of blubber, that's like sometimes a 1 to 2 foot thick layer of adipose tissue to help with thermal insulation. The other thing that adipose tissue does is a way to store large amounts of energy in a not particularly large amount of area. Adipose tissue is generally, lipids in general, are very energy dense. You can store a lot of calories in not as big an area. So it does help with that as well. And this shows you these different tissue types right here. A good review on these ones. Again, having the structure, where you find it, and what is it good at. Again, that's all the stuff that we generally tend to go back to over and over again on these different connective tissues. The dense connective tissues, the main thing with these ones that's different is there's not as much ground substance. So you're going to see a lot of fibers, not a lot of cells, not a lot of ground substance. And we're going to see that there's really 3 main types to this. 2 decently widespread ones and one that's a little bit more specific. So dense regular connective tissue, what makes it regular versus irregular is really just orientation of these fibers. So with dense regular connective tissue, you have all these collagen fibers going, like my fingers, all in the same direction. What this means is this is going to be a tissue that's really good at resisting pulling on the ends of this one, because you have a lot of these parallel fibers. Going to be really strong if you're pulling on the ends of this particular structure, not particularly good if you're pulling on the middle of it. You can see some fibroblast nuclei in between these collagen fibers. You see very little ground substance in there, so you can see here's all these fibers, a nucleus right there, a little bit of ground substance in between, but mainly all these fibers running like this. Sometimes there'll be a little fold to them where they look like a stack of lasagna noodles laid on top of one another. Generally very few blood vessels in here. So if you think about all these fibers are going in the same direction, it means it's going to resist pulling in that direction very well. What structures are always pulled on in the same direction? That's going to be kind of the areas you find this. So where do we find it? Tendons and ligaments generally are always going to be pulled on in that same direction. If you think about your bicep tendon, when that bicep contracts, it's always going to pull on the ends of that tendon to shorten it, shorten the muscle overall. So it's always going to pull on in the same direction. Same thing with ligaments, always being pulled on in that same direction. Generally really strong when they're pulled on in that particular direction. If they're kind of overdone, they can tear. And this shows you the one where these fibers can kind of take on that waviness and, like I said, look like lasagna noodles laid on top of one another. And again, what are they doing? Well, obviously ligaments resisting that pulling in that particular direction by binding bone to bone. Tendons attaching skeletal muscle to bone so we can move these bones past one another, do our different movements, our articulations. Again, really good at resisting that pulling in a particular direction. Dense irregular, well, if regular was all in the same direction, irregular means they're all in random directions. So very similar in terms of structure, lots of collagenous fibers running every which direction this time. Not a lot of ground substance, not a lot of visible cells at all, not a lot of blood vessels. So very similar with the exception that the fibers are running in all different directions. So where do we see this? Well, not surprising, in areas where you don't always know which way that tissue is going to get pulled on. So probably the best example where we find this is it's the main part of what is called the reticular dermis of the skin that we'll talk about in the integumentary system. But if you think about your skin, you never know which way it's going to get pulled on. So the fact that you can kind of, like your grandma or aunt, oh, you're so cute, it does that thing like that. This is protecting that tissue and attaching it well to the layers underneath. We see this around different organs a lot of the time. So you have capsules around things like the kidney, the liver. It's made up of this. We see this around some larger fascicles in the muscle or around the muscle overall. If you've ever had steak and had that grizzle, that's dense irregular connective tissue. So you see it in a lot of those areas. Sometimes we give it a little bit different name with these sheaths around things like cartilage or bone. Might call it perichondrium or periosteum, but again, dense irregular connective tissue surrounding those particular types of tissue. Again, really good at resisting tearing and those unpredictable directions. Ligaments and tendons aren't made of this because they are always going to pull in one direction, and if it was all the different directions, they would not have as much flexibility, so you wouldn't have as wide a range of movement. So we don't do that. One of the things I do want to say about those two real quick before I talk about elastic tissue is that because there is a scarcity of blood vessels in these ones, they do not tend to heal particularly well. Anything that doesn't get good blood supply generally is not going to heal particularly well. So if you think about a tendon damage or a ligament damage, they are generally very slow to heal and a lot of times don't heal particularly well. So if you think about like ACL tears, sometimes it's just not going to get back to where it was beforehand. If you think about like shoulder separations or tears of the ligaments in the shoulder, a lot of times they're not going to get back to where they were originally. So these do not have a tendency to heal particularly well. Generally much longer healing time than something like bone, which does have good blood supply. Like Achilles tendon injury is going to be generally 12 weeks of no weight bearing before you start putting weight on it, where bones it's usually 6 to 8 weeks and you're going to start doing weight bearing. So the last type I want to talk about is elastic connective tissue. This one, again, dense connective tissue, but now the fiber type, not surprisingly, is going to be elastic fibers, which is going to tell us now that it's not just resisting pulling, but it's being able to expand and go back to its particular shape, so that stretch and recoil. We see this in the walls of these very large arteries, things like your aorta, as well as in areas of the trachea and the vocal cords, and male reproductive tract as well. On these ones here, you can see these are all these elastic fibers densely packed in here. This is actually part of the aorta, showing the aorta wall. Main thing with the aorta, when the heart beats, it needs to be able to expand without breaking and then go back to its original shape to maintain the blood pressure so we don't get a weird drop in blood pressure. So, your connective tissues, again, of the dense type, dense regular, dense irregular, and elastic connective tissues. Again, this is a good review sheet on these ones to take a look at. Tells you the things that I really want you to know on each of them. What does it look like? What does it do? And again, where do you find it? So what we'll start moving on to next is going to be the supporting connective tissues. So I'll see you on that one.